Alright, number 5. I want to solve the system of two linear inequalities. And there's a couple of ways that we can do it, either by y equal, or we can pick ordered pairs. So since they ask for ordered pairs, we'll do it that way. And we're going to do the first linear equation, so it's going to be this one first. So we're going to do 6x plus 6y is less than negative 18. So we're going to find the x-intercept by plugging in a 0 for y. That means y equals 0. So basically what I do is I just cover up the y. When you plug a 0 in, that term goes away. So with your x-intercept, we're looking at 6x. We can just say equals negative 18 because that's what we're trying to find. So we got 6x. We can say equals negative 18 and then divide by 6. And that gives you x equals negative 3. So the ordered pair we get here is negative 3 for x, and y value is 0. That's always the case when we do intercept. Alright, and then we'll do the y-intercept. This time x is 0. It's always the opposite. Alright, so when x is 0, you just get rid of that term. You're left with a positive 6. Y equals negative 18. It's almost the same thing. 6y equals negative 18. Divide by 6. And we get y equals negative 3. So this ordered pair, x is 0 this time, and y is negative 3. Now, because we don't have an equal to, we're going to have a dotted line. And the way we determine if we shade above or below that line is if we plug both of these to be 0. So this is 0, this is 0. And we're looking at is this statement, is 0 less than negative 18? If it is true, we shade towards 0. If it is false, we shade away from 0. 0 is actually greater than negative 18 because negative 18 is farther to the left. So this is false. So we will shade away from 0, 0. The ordered pair 0, 0. So we have a dashed line, ordered pairs negative 3 and 0, and 0 and negative 3. And so here's the ordered pair 0, 0. It's on the A side. Since we got false, that means we don't want to shade the A side, we want to shade the B side. Alright, so now we have the second line. X is greater than negative 5. Okay, so this, we don't even have to solve anything, it's already done. This is going to be a solid line. Okay, so the way that you need to envision this, you can pick any numbers you want. So here's 1, 2, 3, 4, 5. Alright, here's x equals 5. Solid line right here. There's a bunch of ordered pairs. X is 5. You can pick any number you want for y. You can pick 5, 2. You can pick 5, 0. You can pick 5, negative 2. Any number you want will work as long as x is 5. That's what that means. X equals 5. So we have a solid line. We have ordered pair. We'll just say 5, 0 and 5, 5. It doesn't matter. You can pick. It's going to be a vertical line here. And this, if your variable is on the left hand side, which it is, this inequality will point you in the direction. So you want to shade to the right, greater than. So that'd be 6, 7, all this D side. So that's what we want to shade on the second line. Okay. Now there's a part 3. Select the region that you want to shade as a union. So what do we have? We have and. So and wants the shading of both, the overlap. So one shaded below and one shaded to the right. The overlap where both shade would be the intersection. So and means intersection. Be the intersection, this little piece right here. And it, I don't know if they shaded anything. I can't really see. But and, the word and means only what both of them have in common. So if I can kind of draw this out, this one shaded this way, and then this other line went down like this, and it was shading below. So the and would be just that little part down there. That's the intersection.